when atoms join together, okay, and the atoms involved are not metals, then a type of bonding that takes place called covalent bonding happens. And I want to show you what this means. So here we go. Okay, when two atoms of hydrogen bond together, this is what happens. Now, for the sake of making this simple, what we've got here is, over here, we've got one atom, and that's got a little electron going around the outside, because remember, hydrogen is in group 1. And here's another one going around. This one's blue, and it's going around here. And that's also in group 1, because it's just hydrogen, it's the same thing. So what happens? Well, both hydrogen atoms need to fill their outer electron shell. So to do this, they share. And this is what happens. When two hydrogen atoms join together, they kind of cheat a little bit, I suppose. The electron from the left-hand atom over here, the grey one, okay, sort of spends half its time on this atom and half its time on this one. And likewise, the blue electron here, when the two hydrogen atoms join together, it spends half its time on this one and half its time on this one. And there they go, whistling around them. Now, they haven't got brains, but if you were to ask this hydrogen atom here on the left, how many electrons has it got? It would probably say, well, I've got a grey one and a blue one. So this hydrogen atom, it's got 2 electrons, and they kind of spend some time going around it. And that is also the case for the right-hand hydrogen atom here. If you asked it, and remember they don't have brains, they're not really alive or anything like that. But if you were to ask it, how many electrons do you have? It would say 2. I've got a blue one and a grey one. So they're kind of both happy doing this. Now what happens actually is that as these electrons are around there, they kind of like attract the positive nucleus because they're negative in electrical charge, and the nucleus is positive in electrical charge, and opposites attract, and it sticks together. And that would be great. So if we had an exam and you basically had to write down or draw down or make an animation which said, well, this is what happens when 2 hydrogen atoms join together, you'd be fine. Unfortunately, exams don't come with animation equipment, so we have to learn the old-fashioned way of representing what's going on. And it's not so simple. We draw it a bit like this, okay? And we have a little crossover region in the middle, which sort of shows that the grey electron here from the left hydrogen atom is sort of shared between the two. You see this little area of overlap down there? That's what we're talking about. And the blue one, okay, that was in the right-hand hydrogen atom, that is in this little shared area, if you like, because that's being shared between the 2 atoms. Now, we don't normally draw the circles because most people are rubbish at drawing circles, and so we use the chemical symbols for hydrogen, which is H, and we don't have to do the circles at all, so we can just draw these in there. Now, this is in colour, and it's easy to see. In the olden days, before colour was invented for textbooks, they had to use just black and white, and so very often we used 2 black dots. Hang on, you can't tell the difference between 2 black dots. That's right. So one of the dots gets substituted for a cross because we're just wanting to show in a symbol way what's going on. So let's move on and let's see what happens when we look at something a bit more complex. So here we go. We've got 2 atoms of chlorine. Now here they're colour-coded. This one's blue, that one's red. And we're actually only interested in the outside atoms. And when chlorine atoms, which are non-metal atoms, join together, they join together and, oh, there we go. Well, they share 1 electron each. Why 1 electron? Well, it's fairly straightforward. Chlorine's in group 7, so it's got 1, 2, 3, 4, 5, 6, and 7. And it only needs to share 1 electron to have a full outer shell. And the same for this blue one over here. That's got 7 and only needs to share 1. So when the electrons are shared, And remember, they're kind of like spending half their time on one atom and half their time on the other. But these two will help both atoms to feel like it's got a full outer shell. So this red electron atom over here, that one will spend some time going around here, some time going around there, and this one, the blue one from this side, will spend some time going around here and some time going around there. So both of these atoms have full outer electron shells, 8 in total. Now, we don't call it Cl anymore, we call it Cl2, and that's chlorine. It's a molecule of chlorine because it's 2 atoms joined together. And if we were to get rid of all of the baggage, all of the other rest of the diagrams, we'd draw some crosses for some of these electrons, and we draw these dots over here, and that's why they're called dot and cross diagrams. Okay, let's move on. Let's do one more quick example. Okay, this is oxygen, and there's another oxygen there, and there's a carbon in the middle. 1, 2, 3, 4 for carbon, that's why carbon is in group 4. 1, 2, 3, 4, 5, 6 electrons in its outermost shell for oxygen. 6 electrons, that's why it's in group 6. Now, to make a total of 8 and to have a full outer shell, oxygen needs to borrow, on a part-time basis at least, it needs to borrow 2. Carbon needs to borrow 4 in total, and it can borrow 2 from this. And there's another oxygen over here, and the same story on this side. Oxygen has 6 electrons in its outermost electron shell, needs to share or borrow 2, and so it's probably going to pair up with these 2 over here, and at the same time carbon will be able to borrow some from over on the right hand oxygen, and that's what that looks like there. So getting rid of all the rest of the stuff, okay, we have a dot and cross diagram for CO2, and it looks like this. We've got the symbol for oxygen and the symbol for oxygen there, carbon here. And in this little area, which we're saying is where the sharing takes place, we've got 2 oxygen electrons, and it's sharing them with this carbon atom. And at the same time, the carbon atom is sharing 2 of its electrons. So if the carbon atom looks out, it would see 1, 2, 3, 4, and on this side 5, 6, 7, 8 electrons in its most outer shell, and the oxygen atom here would see 1, 2, 3, 4, 5, 6, 7, and 8 electrons, so its outer electron shell is full, and 1, 2, 3, 4, 5, 6, 7, 8. This oxygen atom would also see 8 electrons in its outer shell. The covalent word means this. Co means like sharing, you cooperate with people, and the valency bit is sort of talking about the electrons. So that's how nonmetals join together, and these are called dot and cross diagrams.